The daemon. Central to the belief system of the ancient Greeks was that all human beings consisted of not one but two independent entities, a lower everyday self called an eidolon and an immortal transcendental being they called a daemon. The idea of this daemon-eidolon duality was to fascinate the ancient Greeks, and soon a whole philosophy of universal structure was to be built around this relationship. The earliest known writer on the subject was Empedocles. For him, the daemon is a divine being exiled from its rightful place among the gods. It exists independently of its eidolon and has great knowledge and power. Plato tells that throughout his life his great teacher Socrates had assistance from a guide. Socrates called this disincarnate voice his divine sign. From childhood this voice had communicated to him its opinions on what he was doing or intended to do. According to Plato, this voice forbade Socrates from doing things and regularly gave prognostications on whether good or bad luck would follow from certain actions. It is as if Socrates' divine sign was directly aware of the philosopher's potential future. Indeed, Plato was at great pains to point out that many of these predictions were marked by extreme triviality, as if the spirit was tied very closely to the minutiae of Socrates' life. According to Epictetus, another ancient Greek philosopher, the daemon is more than simply another facet of human nature. It's an independent being that watches over its lower self. He wrote, "God has placed at every man's side a guardian, the daemon of each man who is charged to watch over him, a daemon that cannot sleep, nor be deceived." To what greater and more watchful guardian could have been committed to us? The Romans also had an ancient but widespread belief that each man had his own attendant spirit that followed him throughout his life. This being, termed his genius, was born with him, and as such was honoured therefore by each individual on his birthday. This belief carried through into Christianity, in the guise of Gnosticism. According to the Gnostics, the universe was under the influence of two conflicting forces, light and darkness. Human beings are in turn a reflection of this duality. Our soul is a spark that comes from the light. It is therefore part of the positive side. However, our bodies are made up of matter. Matter is part of the darkness. This creates an ongoing conflict within the human condition. Man is imprisoned in this body of darkness, but part of him retains memories of his divine origin. The part of man rooted in the darkness equates to the eidolon. This being is made of matter and will cease to be when the body dies. However, that part of him that retains the memory is the daemon. The great Gnostic philosopher Valentinus taught us that a person receives day-to-day assistance from what we now call the guardian angel. For the Gnostics, that being simply was that person's own higher self. This implies that the angels that communicate between the world of light and the world of darkness are not independent beings at all. They are daemons from this world. We are our own teachers. We've now completed our review of the experiential, empirical evidence for my CTF model, but as has been stated many times, the plural of anecdote is not proof. I now need to make my case from science, both known and theoretical. It is this we now turn our attention. Evidence from science. Neurology, neurological duality. I would like to start this section by evaluating the evidence that human consciousness is dual. I introduced a concept I call the daemon-eidolon dyad in my 2008 book, A Daemon, A Guide to Your Extraordinary Secret Self. This presents extensive reviews, both neurological and psychological, as to how this may be. With the word count constraints on this essay, I would like to focus on a small part of the evidence presented in that book. If you wish to investigate this further, please check out the book. Though human consciousness may be dual rather than a unitary, may fly in the face of common sense. But for those who study the brain, such an idea is not only possible but probable. A quick review of brain anatomy cannot but support such a proposition. The most immediate thing that strikes you when you observe a brain for the first time is that it is not in fact a brain at all. It is two virtually identical brains joined together by a mass known as the corpus callosum. Every structure contained in one side is mirrored in the other, with one curious exception, the pineal gland. There are two of everything, two limbic systems, two temporal lobes, two amygdala, the list goes on. Neurologists have long been puzzled by this. Why should the brain be structured in this way? Indeed, the puzzle has deepened in that it has been shown that certain individuals continue as normal people even when one of the hemispheres is damaged or removed. In the last 60 years or so, surgery has advanced to such an extent that the corpus callosum can be cut and in doing so, the two hemispheres cease to have any line of communication. When this is done, these patients literally have split brains. They also end up with two independent centres of consciousness. The implication of this is both clear and mind-blowing. We have two independent beings sharing our perceptions. Usually the two hemispheres work in tandem, generating a constant stream of inner dialogue that gives us our sense of self. Meanwhile, the right hemisphere is still actively involved in all cognitive processes, working away in the background. However, and here comes the surprise, the being that is known as I or me is generally wholly unaware of what its silent partner is up to. For most of the time, I is entirely unaware of its partner. Problems arise when the two fall out of phase. Suddenly, I sense us. However, it is much more disturbing than that. But it's sensed not as self, but as other. To the experiencer, this sensed presence is not themselves at all, but an outside ego alien being. The late Michael Persinger of the Laurentian University in Sudbury, Canada, spent many years studying this peculiar psychological effect. He called it the visitor experience. He was able to reproduce the sensation under laboratory conditions. Persinger considered that the experience shows a linear progression. At its weakest, the subject just feels that they are not alone, that there is something else in the room that they cannot see. However, at its strongest, the subject perceives an objectively existing being of tangible reality, a being that has greater emotional significance to them. For some, this may be perceived as an angel or even a god. What is very interesting is that if the lower portion of the temporal lobes become activated at this time, then long-dormant memories may spontaneously enter the subject's mind. The being will then communicate information that seems intensely personal. This may be interpreted as telepathy or an omnipotent knowledge. But there is more. According to Persinger and his team, past life memories can be evoked in a panoramic life rerun that is identical to the panoramic life review we have already encountered in our discussion on the near-death experience. This is of enormous significance for my CTF model because it suggests that this facility is a universal element of brain functioning. Why should this be? What evolutionary advantage can be gained from having a subliminal memory of previous experiences? According to Bruce Grayson, the being of light is really an external projection of the experiencer's non-dominant consciousness. If so, it would certainly explain how this being shows such intimate knowledge of the dying person's past life. Could it be that this being is an independent focus of consciousness that has shared the life of its alter ego? Could the experiments of Persinger show that my concept of the daemon is a very real aspect of every human being's neurological makeup? Indeed, is Persinger's God helmet simply opening up the communication channels with the daemon? This is an area I plan to explore in much greater detail in the future should funding be available. Persinger also observed that during sessions with the God helmet, volunteers reported a dilation in time perception. Sessions seemed to take much longer in subjective time than in clock time. As we have discovered, this is yet another of Bruce Grayson's identifiers regarding the near-death experience. Can science also give us an idea of what might be taking place here? Neurology, time perception. One of the world's major researchers exploring the neurology of time perception is Stanford University's David Eagleman. Whilst working at medicine at Baylor College in Houston, Texas in 2007, he conducted a series of experiments involving volunteers experiencing a form of extreme sport known as suspended catch device diving, or SCAD. In doing this, he was able to reproduce the sensation of falling similar to those reported by Albert Heim discussed earlier. This process dropped volunteers 150 feet into a catch net. Of crucial significance regarding the theme of this essay, all of the volunteers reported that they were falling, that their sense of subjective time duration slowed down. Stetzman, Fiesta and Eagleman et al. Announced that this provided the objective time. This proved that objective time did not change, that it was a neurological effect. Indeed, this also seems to prove an extremely stressful situation will facilitate a subjective slowing down of time. And dying is probably the most stressful scenario imaginable. So the question has to be, why have we evolved such a perception? If it is entirely subjective, what is the evolutionary advantage does it give? The person does not objectively move any quicker, so evasive action to avoid danger will be no more effective because the body will only move at normal speed. If the brain can slow down subjective time perception under certain neurological conditions, can it also speed it up? This suggests that what we consider perceptual reality is more like a recording that we are experiencing than something that objectively exists outside of us. In German, a Zeitraffer is an apparatus that can accelerate or slow down the speed by which the individual frames of a cinefilm are processed. Significantly, this apparatus has given its name to a neurologically induced perceptual anomaly, first reported by Ferdinand Binkowski of the Department of Neurology of the Heinrich Heine University in Germany and Richard A. Bloch of the Department of Psychology at Montana State University. Bloch and Binkowski report that a right-handed 66-year-old retired clerk with no history of neurological disease was driving his car along a German road. The man, known as BW, was horrified to discover that suddenly external objects started rushing at him at great speed. As he described it, it was as if somebody had pressed a fast-forward button. He also found that his car was running at fantastic speed. He could not control the vehicle as his reaction time remained normal. He found himself driving through a set of red traffic lights because he simply could not stop. He slammed his brakes on and stopped the car. He watched in horror as the world around him still ran around him at super speed. This state continued for him, and 2 days later, in a state of general stress, BW was admitted to the Heinrich Heine Neurological Hospital. Here he described what was happening as an accelerated motion of events like a time-lapsed film. He complained that he could no longer tolerate watching television because the progression of events was too quick for him to follow. He also described that life had begun to pass by too quickly for him. On his admission to the hospital, a CT scan showed that he had a lesion on his dorsolateral prefrontal cortex. He was then given a series of tests. He showed no problem with time orientation. However, when asked to decide how long a 60-second period was for him, some strange things were discovered. BW was told to say when he wished to start and then remain silent until he felt that a minute had gone by. He was then to say stop. They repeated this test many times, and according to his BW's subjectual average minute was 286 seconds. It was then discovered that BW had a glioblastoma tumour centred in Brodmann's area in the prefrontal cortex of his left hemisphere. Sadly, he died soon after without ever regaining normal time perception. What is intriguing about this paper is that the two scientists suggest some interesting possible explanations, including the one that we all have an internal pacemaker that controls how we subjectively perceive time duration. However, they finish off by writing, "It is unclear how best to explain the phenomenon." In recognition of the similarities with the speeding up of film frame rate, this illness is known as the Zeitraffer-Elbness effect. The first report of subjective perception's accelerated motion was reported in Germany in 1919, and several cases have been reported since. In 1959, neurosurgeon Wilder Penfield and his associate S. Mullen recorded 3 instances of this Zeitraffer phenomenon, including one patient who described their sensory world as being like a movie going slow motion. Fred Ovzeu of the Feinberg School of Medicine in Chicago reported a case in 2013 in which a 39-year-old man described that whilst in the shower he perceived the water droplets suddenly hanging in mid-air. He likened this to the way the bullets travelled in the Matrix movies. He was diagnosed with a hematoma on his right temporal lobe and subsequently developed temporal lobe epilepsy. The link here to TLE is of extreme importance. I have focused on TLE as a facilitator of NDE-like experiences in non-near-death situations in many of my books. I have presented this case as a robust neurological evidence for my CTF hypothesis. For example, in my books Opening the Doors of Perception, the key to cosmic awareness. A closely related neurological condition to Zeitraffer-Elbness is kinetopsia, which is a defective perception of moving objects. This has the patient see objects as being freeze-framed or jumping from one location to another, as if some frames were missing. It is believed that this is caused by damage to cells in an area of the brain known as the extrastriate visual cortex, area V5. This is precisely how mathematical physicist Julian Barber believes the world to be. In his books The End of Time and The Janus Point, A New Theory of Time, he argues that time is an illusion, and that what we actually perceive are a series of static images. These are sourced from a location outside of time and place that in a place he terms as Platonia, a timeless realm containing every possible now or momentary configuration of the universe. When functioning effectively, the brain creates an illusion of time time flow by processing data uploaded from Platonia into its processing system. In effect, Barber suggests that the brain's role is to create an illusory space-time in which we can experience our lives. Neuropharmacologist Andrew Gallimore, in his extraordinary book Alien Information Theory, Psychedelic Drug Technologies and the Cosmic Game, takes this to its logical conclusion, proposing that we are all existing in a simulated reality, something he calls an instantation. In this deeper reality, which all our myriad of lives are played out, is this the deeper reality in which all our myriad of lives are played out? In a timeless, spaceless mathematical program? Are we actually within a super complex virtual reality computer game that contains every outcome of every decision we can or may make? CTF suggests that this is the case. And now we turn to the evidence for this, and it's all known or theoretical science. In other words, it's not only possible, but highly likely. Physics, the anthropic cosmological principle. If our perceptual universe is indeed an instantation, as Andrew Gallimore suggests, then there should be clues that this has been designed in the same way that a computer program is designed. It will show what is known as teleology, that is, that there is a plan. And with regards to this universe, it seems the plan was the creation of consciousness. Impossible? Well, let's look at some of the scientific facts. In 1974, British astrophysicist Brandon Carter commented upon how it seemed that the universe had engineered many variables to coincide in such a way that self-conscious life was evolved. He called this the Anthropic principle. Carter had subsequently been quoted that he wished that he had used another term. Anthropic suggests a uniquely human focus, whereas he argued that the universe was hardwired for intelligent life, human and non-human. On reflection, he considers that biophilic principle would have been a much more accurate descriptor. Carter's principle has evolved into two variations, the weak anthropic principle, WAP, and the strong anthropic principle, SAP. WAP proposes that to have evolved intelligent carbon-based life forms, the universe has to be the size and age it is. In addition, it has to have the mixture of elements that is observed, because without this structure we would not be around to observe the fact. This is in effect what the proponents of various many worlds interpretation theories suggest. SAP, on the other hand, is far more revolutionary. It proposes that the universe has been in some way hardwired to develop the way it has for us to evolve, and these small tunings were being manipulated from the Big Bang onwards. For example, gravity has a fine balanced relationship with the nuclear strong force. If gravity had been very slightly weaker in the early stages of the Big Bang, matter would have dispersed too quickly for stars to have formed. However, if gravity had been slightly stronger, then the universe would have reached a maximum size, then recollapsed in a big crunch before carbon-based life had the time to evolve. Indeed, carbon and associated heavier elements are crucial to life. It is only the heavier elements that can form complex atomic structures among themselves. The lighter elements cannot do this. But the Big Bang only created the lighter elements, which, by the exact amount of gravitational force needed, were pulled together to create nebula and in turn the first stars. Only when these stars exploded at the end of their lives were these heavier elements created. And it is to the wonders of carbon we now turn our attention. Without carbon, all of nature would be inanimate. So where does carbon come from? Within all stars, chemical processes are taking place at all times. Atomic nuclei are colliding with each other, bonding with each other, or smashing each other apart. Massive amounts of energy are thus released, and together with the energy within the star, assist in the creation of new compounds. It's within the stars that carbon is created, vast amounts of it. However, without the most amazingly fortuitous set of chemical circumstances, carbon would simply not be. Carbon is formed by the rare triple collision of three separate helium nuclei. When two helium nuclei collide, they immediately create a new larger nuclei. This new nucleus is an isotope of the hard white metal beryllium. This is known as beryllium-8. Now, beryllium-8 is a very unstable isotope that has been created artificially on Earth. It's so unstable that it spontaneously fissions, that is, splits, into two alpha particles in less than 10 to the minus 15 seconds after it is formed. The third helium nucleus has to collide with the newly created beryllium-8 nucleus within that short 10 to the minus 15 second period for carbon to be created. But this is not the end of the story. The third helium nucleus has to hit and therefore contribute precisely the right amount of energy to ensure that the newly created nucleus of carbon, actually the most common isotope of carbon, carbon-12, is stable. If the new nucleus has too much energy, it must either divest itself of any excess kinetic energy that it does not need, or eject a particle. In many cases, the two colliding nuclei will fail to stick together, resulting in a very swift ricochet and a continued existence of quantum singularity. However, if the amount of energy resulting from the collision is precisely right for the new nucleus's natural level, the conversion of lighter nuclei to heavy nuclei was worked perfectly. This set of conditions is called resonance. To ensure that the newly formed isotope of carbon-12 does not suffer fission, it has to be in total energy balance with the two contributing isotopes, helium-4, beryllium-8. And unfortunately, this is the case. However, our newly formed carbon-12 has other potential hazards to overcome. As we have seen, the carbon-12 molecule has been created by the impact of 3 helium-4 nuclei. Obviously, there is a lot of these flying around. It's therefore logical that within a short period of time, our new carbon-12 molecule is going to collide with another helium-4 alpha particle. When this occurs, and if there is the appropriate resonance, the carbon-12 and helium-4 will fuse into oxygen-16. Now, this is where the whole process seems to be designed to ensure that carbon survives. The nearest oxygen-16 resonance has 1% less energy than the helium-4 plus carbon-12. But this 1% is all it takes to ensure that resonance does not occur. So in simple terms, if the oxygen energy levels were 1% lower, then virtually all the carbon made inside the stars would be processed into oxygen. Then much of it into heavier elements still, such as carbon. Without this, all carbon-based life forms like ourselves simply could not exist. Another of the heavier elements created in the first stars was oxygen. Together with hydrogen, this creates another one of these curious coincidences that have facilitated the creation of life and consciousness within a seemingly inanimate universe. When two hydrogen atoms link with a single oxygen atom, something magical is created that has no similarities with its parent atoms. It's called a water molecule. The atoms form in a triangular molecule whose electrical charge is unequally distributed. It is polar because the oxygen side of the triangle is negative and the opposite side, with the two hydrogen atoms, is positive. This structure allows water to be particularly crucial in the development of life. For example, it creates surface tension which supports the formation of cell membranes. As it is less dense its solid state than its liquid state, water freezes from the top down, not the bottom up. This means that the oceans have never frozen solid. If they had done so, all marine life would have been killed, and life would not have started in the oceans. Other important properties of water include its solvency, its cohesiveness, its adhesiveness, and other thermal properties. There are many more examples of these coincidences. For a full view of the Anthropic cosmological principle, check out the book written by Barrow and Tipler in 1986, and for a recent update of the concept, read Paul Davis's work from 2007. Could it be that the universe has been hardwired since the first femtoseconds of the Big Bang, when there had to be a tiny fraction more matter than antimatter for matter to become the dominant physical characteristic of the universe, for self-aware consciousness observers to evolve? If so, why is consciousness so critical? It could be that without consciousness to observe it, the universe could not exist, not even in those earliest times after the Big Bang. Confused? You should be, but this will all now become clear. Physics, the observer problem. Each sentient consciousness observes the world around it through its senses. The brain uses data from various sensory inputs to create an internally generated model that allows consciousness to negotiate the seemingly independently existing environment surrounding it. Consciousness does this by controlling a body that is apparently part of the environment, a body made up of flesh and bones and created out of the same materials that the universe is made of: atoms, quarks, and electrons. This body has direct relationship with the observing consciousness, because when willed, the consciousness can move the body to execute actions it desires, as I am doing this now by using my fingers to type these words on my computer keyboard. But consciousness, the point of awareness that each of us is not made of atoms, quarks, or electrons. It is a will that uses the brain as a medium by which it interacts with the world. This will is non-physical and occupies no space, and yet it seems that this ephemeral point of awareness may bring into existence the world it perceives. This is because of the discovery that light, electromagnetic energy, is both a wave and a particle. These are very two different things. A wave is a disturbance in a medium like water wave. It is something that spreads out in space and time and flows around obstacles. A particle is a bit of physical matter that has mass. It has specific location in space and time. But something known as the double slit experiment has shown that light sometimes acts as a wave and sometimes as a particle. As I discussed in my first book, Is There Life After Death? The Extraordinary Science of What Happens When We Die, on pages 18 to 24. Well, what is strange is that it makes light choose to be a wave or a particle, depending upon whether it is observed or not. By observed, we mean measured by a sensing device. But a mechanical object is not what does the measuring. This only becomes an objective metric when a mind evaluates the measurement. A set of scales has no idea what a gram is, just as a ruler has no idea what an inch is. And so it is with the double slit experiment. It is a mind that observes the wave, the particle, not the measuring device. And this is where the problems start, because the generally accepted model of quantum physics, known as the Copenhagen interpretation, tells us that what exists is a mathematical structure known as the wave function, a statistical wave that contains the potential to be either a particle or a wave, so that all can be determined is the probability of one outcome versus the other. According to the Copenhagen interpretation, the only way to determine the outcome is to look. The act of observation itself collapses the wave function, supplying a definite answer to the question. This effect has been observed in countless experiments. But what is stranger still is that this wave-particle duality has been observed not only with photons, but electrons, tiny bits of matter, then atoms, then molecules, large molecules. Indeed, recently, Austrian physicist Anton Zeilinger and his team at the University of Vienna have shown that even larger molecules, such as the interesting named C284, H190, F320, N4, S12, which consists of 800 atoms, shows wave-particle duality. The physical world we see around us is made up of molecules, as indeed is the human body and the human brain. Together with the chemicals that facilitates that brain in its supposed creation of consciousness, the location of the observer who brings about the awareness of the very particles that bring about their existence. This is an extraordinary discovery. It means that there is no such thing as objective reality, including the human brain and everything it perceives. Reality and all it contains is not determined until it is observed. In 1925, the Austrian physicist Erwin Schrödinger created a mathematical formula describing how quantum matter waves evolve in space and time. He argued that there was no collapse of the wave function, it just continued. He found the idea that consciousness was involved in bringing about the supposed collapse to be preposterous. And to show how illogical it was, he proposed a thought experiment to highlight the quite ridiculous implications. In an article published in the science journal Naturwissenschaften, he imagined that, quote, a cat is penned up in a steel chamber, along with the following diabolical device, which must be secured against direct interference by the cat. In a Geiger counter, there is a tiny bit of radioactive substance, so small that perhaps in the course of 1 hour, one of the atoms decays, but also with equal probability, perhaps none. If the atom decays, the counter tube discharges, and through a relay releases a hammer which shatters a small flask of hydrocyanic acid. If one has left this entire system to itself for an hour, one would say that the cat still lives, if meanwhile no atom has decayed. Now, during the hour, there is let's clarify on this. Schrödinger argues that during the hour, there was a 50-50 chance that the radioactive substance will decay at some time in those 60 minutes, bringing about the cat's death. But there's also a 50-50 chance that it will not decay and the cat remains alive. But if the atom is unobserved, then it is in a state of superposition in which its wave function does not collapse. Then there exists two cats, one alive and one dead. It is only when the box is opened that the observing scientist brings about the collapse that results in a dead or alive cat. In effect, this means that one set of circumstances simply disappears, while the other spontaneously comes into existence. Could it be that everything around us is being brought into existence as we observe it? This is the only conclusion that can be withdrawn from the Copenhagen interpretation, and it powerfully supports the Anthropic cosmological principle argument that the universe needs consciousness to evolve for its collective wave function to be collapsed. Without conscious observers, the universe and everything in it is simply a statistical wave function, a mathematical construct with no actual reality in itself. Or is it? In 1957, Princeton student Hugh Everett III submitted his PhD thesis suggesting a solution. He agreed with Schrödinger that the wave function never collapses but continues. So far, so good. But then he argued that the wave function splits into two at the point of measurement, one to accommodate a universe containing a dead cat and one containing a live cat. He then argued that as the box is opened, the observing scientist and his whole universe also splits into two versions, one of which a dead cat is observed and one containing a live cat. This has become known as the many worlds interpretation, and so consciousness and the collapsing wave function are taken out of the equation. In effect, this means that there will be a version of you and every other consciousness that will experience every possible outcome of every decision that you can and will make. Not only this, but all decisions made by your ancestors will also create new versions of you. And this is of great importance. For the question being asked in this essay, you may die in one universe, but in a version of you will always survive. Let's review this in more detail. Firstly, many worlds interpretation suggests that the wave function never collapses but continues with all possible outcomes coming into existence. In doing so, the outcome of every possible wave function involves the creation of a number of new universes to accommodate the evolution of each wave function. And in each universe there will be an observer who will measure the outcome of each quantum event. In effect, this means that there are countless universes, some virtually identical to this one, and some others totally different. In some universes life will have evolved, and in countless others the conditions will be hostile to life. This hypothesis explains all of the coincidences that brought about life in this universe, and as such destroys the idea that in some way the universe was hardwired for the evolution of life. We just happen to exist in a universe whose wave function evolved to facilitate life, and ultimately conscious observers. This universe was not designed for life. It is simply one of a number whose chance conditions coincided to create life. This may seem to invalidate my carefully structured argument for cheating the ferryman, but it doesn't. Indeed, it offers an alternative scenario that also supports the hypothesis. Why? Well, if there are countless universes, then there are innumerable versions of every conscious observer within the Megaverse, and each one will experience numerous times every possible outcome of every decision they can make in their lives. Not only that, but there will be a universe in existence that will accommodate the consequences of every decision that the ancestors of that consciousness will make in the past. This can also be extended into the future. What is more, all of these universes may be existing concurrently, so that at the present moment in time, all outcomes of all decisions already exist waiting to be experienced. This can be related directly to the final writings of the great physicist Stephen Hawking. In a paper published in 2006, Hawking and his associate Thomas Hertog of CERN Research Centre in Switzerland proposed that the outcome of every event was encoded into the fabric of the universe from the first femtosecond of the Big Bang. In this model known as the top-down hypothesis, Hertog and Hawking ask us to visualize a universe with trillions upon trillions of movies all running on top of each other. This is the real universe. All we do is perceive one slice of this mega-reality. But what is crucial to understand here is that for Hawking and Hertog, this multiverse exists in another form of time that is not the nice linear one of many modern scientists still wedded to the certitudes of a Newtonian universe. He calls this imaginary time. But this does not mean that it's not real. Hawking describes it in this way, quote, "One can think of ordinary real time as a horizontal line. On the left one has the past and on the right the future. But there's another kind of time in the vertical direction. This is called imaginary time because it is not the kind of time we normally experience, but in a sense it is just as real as what we call real time." Unquote. This is similar to the fact of the outcome of every decision in a VR simulation game is already programmed into the DVD or encoded within the computer hard drive. This is also crucially important regarding my CTF model, and yet more proof that it has validity. Another alternative explanation for the seeming fine-tuning of the universe is known as the internally inflating universe, or EIM. Using similar logic to dismiss the Anthropic principle, its supporters propose that this universe is one of countless numbers of bubble universes. Intelligence observers exist only in the rare bubbles in which by pure chance the constants happen to be just right for life to evolve. The rest of the multiverse remains barren, but no one is there to observe them. Each bubble is a disconnected region of space-time. The model was first suggested by Alan Guth of the Massachusetts Institute of Technology as an element of his inflationary model, which attempts an explanation as to why the universe is extremely homogeneous in all directions, even though separated regions have long been causally disconnected. Like in Everett's many worlds interpretation, countless universes contain a version of each consciousness, all evolving in space-time in different timelines. In 2011, Stanford University physicist Leonard Susskind, one of the major theorists involved in both the bubble universe model and the black hole information models, co-authored a paper with Berkeley physicist Ralph Busso. They stated that the inflating megaverse and the many worlds interpretation are effectively the same things. In a fascinating and extremely pertinent analogy, Busso asks us to imagine how the megaverse would look from the viewpoint of a being that could see all possibilities developing simultaneously. In effect, this would be a multiverse of zero probabilities. Every possible outcome of every set of circumstances would all come to pass in at least one of the multiverses. So everything that can happen does happen somewhere in the megaverse. Coming directly from this is another quantum physics model hugely supportive of my cheating the ferryman. It's the relational interpretation, RQM, first suggested by Italian theoretical physicist Carlo Rovelli. In effect, this indicates that different observers will perceive reality in different ways. There is no objectively real version, just what each of us creates from our expectations and beliefs. This solves the measurement problem and the issue of Schrödinger's cat being alive and dead, because we effectively perceive either in our own universes. Rovelli describes this in his 2021 book Helgoland. And it was an incident that took place in 1985 that was to stimulate an intriguing variation of the Schrödinger cats in which human subjective immortality can be proven by using science rather than speculation. Physics, quantum suicide. One morning that year, a student was riding his bike through the streets of Copenhagen on his way to school. As he approached a cross street where he always turned left, he considered whether there was any point in looking right, as there was never any traffic in that part of the city at that time in the morning. For some reason, he felt it was of great importance that he did look. As he did so, he saw a speeding 40-ton truck bearing down on him. He slammed on his brakes just in time. Had he not done so, he would have been killed instantly. The young student was Max Tegmark, now one of the world's leading theoretical physicists. In a recent book, he observes that his decision to look or not look right all came down to, quote, whether a single calcium atom would enter a particular synaptic junction in my prefrontal cortex, causing a particular neuron to fire an electrical signal that would trigger a whole cascade of activity by other neurons in my brain. Unquote. In 1997, Tegmark took the implications of his life or death decision to its logical conclusion by applying the implications of Schrödinger's cat, the Copenhagen interpretation and the many worlds interpretation, to imply that death may be something that only happens to other people. He proposed a thought experiment similar to Schrödinger's cat. He asked us to imagine that a machine gun is attached to a device that measures the Z-spin of a subatomic particle. All subatomic particles have this, and this can be either up or down. However, the direction of spin is entirely random and cannot be predicted for any single particle. If the device senses a particle with a down spin, it instructs the machine gun to load a single live bullet into the stock. If the particle spin is detected as up, the gun stock remains empty with the weapon just making an audible click. To test the gun, an experimenter stands in front of the gun and asks her assistant to pull the trigger. The assistant nervously follows the instructions and presses the trigger. The device detects that the particle spin is up and does not load a bullet into the stock. The gun makes an audible click and the experimenter remains alive. The experimenter suggests that they now go through a further 9 repeats of the experiment. She stands in front of the gun and on each occasion the stock remains empty. After the 10th repeat, she tells her assistant that it is time to end the test and go home for the evening. The experimenter feels satisfied that she has proven to herself that the many worlds interpretation has been proven correct, and invites her relieved assistant out for a quick celebratory drink. Now, let's go back to the start of the experiment and experience it from the viewpoint of the assistant. He follows the instructions given by his boss. He presses the trigger 3 times, and on each occasion the gun clicks. However, on the 4th attempt, the subatomic particle has downspin, the bullet falls into the stock, and the triggers engage. A bullet flies out of the barrel and crashes through the skull of the experimenter, killing her instantly. In a blind panic, he phones the police and is arrested for murder. So what happened here? Is the experimenter alive or dead? Did they go for a drink, or did the assistant face a murder charge? Tegmark argues that in the same way that Schrödinger's cat is both alive and dead in different universes, so is the experimenter in her universe. She did not die, but she did in the universe of her assistant. The crucial point here is that the only reality that the experimenter can possibly perceive is the one in which she survives. Although this is a thought experiment, it has a direct relationship with this essay's subject matter. It proves using empirical science that personal immortality is not only possible but probable. Not only this, but modern science can also provide a location in which these alternative lives can be lived. It's called Hilbert space. This is the mathematical construct that contains all the possible solutions of the variables in the Schrödinger equation. In effect, it is a space in which contains the wave function that have not collapsed in this one. Although this is mathematical rather than a physical location, academics such as Tegmark argue that what actually creates the seeming physical universe that surrounds us is mathematical information. This is not as strange as it seems. If one dons a virtual reality headset, one is immediately thrown into a seemingly real 3-dimensional world. Yet this reality is created from digital information processed using mathematical equations. Could it not also be the case that we believe that to be the physical universe is similarly created?